Good morning and welcome to the CCIF Education Series webinar. I am your host, Patrice Marcel. I'm very pleased to welcome every one of you today on this March edition of the Education Series webinar. This is the second offering that we are doing. We had our first one in December. Now we're already in March. Can you believe that? And we are doing our second run here at the webinars. And again, welcome everybody here. It's very nice to have you all on board here. So the Education Series webinars, what it is exactly, we're looking at 60-minute events, strategically, from a calendar perspective, placed between the main CCIF events. So we're going to have those webinars offering in March, July, and November. We have two sessions at each of these dates. So we have a technical webinar like we have this morning, and then we have a management webinar as well, which we're going to have tomorrow. The topics are selected. They're pretty much follow-ups from CCIF meetings. We ask the audience to participate, to give us feedback. People who would be interested in participating or share a topic or things like that. I mean, this is how we come up with the topic of discussion that we present to you. So if you have any suggestions or if you would like to present, just reach out to Caroline at caroline.lacasse@ccif.ca, or you can go straight to the CCIF website. And if you click on the About tab and you work your way down, you're gonna find the speaker guidelines, and you can just fill in an application form, and then maybe you will be the next presenter. So that being said, we have a session tomorrow. Before we go into today's session, I just want to remind everyone that tomorrow morning, same time at 11 a.m., we have an OEM repair procedure best practices with Mike Anderson from Collision Advice presenting. If you have not signed up for this event, I invite you to do so. Just by going to the CCIF website, you can find all the information again for the registration for this one. Now, a little bit of housekeeping before we move to our presenter here. Microphones are muted, of course. I mean, we're expecting quite a big crowd today. Use the Q&A if you want to ask a question. So just hit the Q&A button, put your question in. I see that some people are already using it and chatting here, so this is fantastic. But if you have any question, I'll be monitoring this box there, and I'll bring them up to our speaker here. You can also chat with participants, with one another, by selecting the participants, and you can chat. There's a poll feature. I don't think that we are going to be using polls today, but you can definitely, if you have questions, please feel free to ask them. And the nice thing about all this is that this session is recorded, and then you have access to, you will be able to go back and look at it again to the CCIF website. So this is great. Thanks to all of this would not be possible without the support of all our sponsors here. And I can tell you that representing one of them, I can tell you that's tough. It's been tough. So it's this is great, and we want to make sure that we thank all of our sponsors here, because this is great. We wouldn't be able to bring this quality content here at no charge to you, and that's what the CCIF is supposed to be doing, and this is what the CCIF is about. So we're very happy to bring this event to you this morning. So today's session, finally we're getting there. Strategic repair planning for diagnostics and ADAS. Wow, there's a couple of key words here in that topic. So who's going to be doing this today? So, well, our presenter is Nick Dominato. Nick's been has been on the news lately. So Nick is a senior vice president business development at asTech. He co-founded ADAS Think, an estimate intelligence software business that allow body shops to upload an estimate, and the software automatically identifies required ADAS calibrations. It provides links to the OEM documentation verifying the repair requirements, and also identifies equipped ADAS features. So Nick is going to be our presenter today, and he's also going to be with Nick. We have Anthony Iaboni from Collision 360. Anthony, you're gonna see videos. He's not on the video, but he's definitely the guy holding the camera, and he's been very helpful for this. And I want to acknowledge his participation here in this webinar. Also, I want to special thanks to David Friars. I mean, the video you guys are going to see, I mean, that was done on Saturday in the shop, and David welcomed, I mean, us in his shop to, and you know, kind of shared some of the work that he's been working on, and this is fantastic, and really want to acknowledge David's support here and participation. So thank you very much, David. This is very, very appreciated. So without you know, that's enough of me. So I would here introduce Nick Dominato. So Nick, the show is yours now.
Good morning, everybody. So glad to have you guys. We're going to dive in today. We've got a great video that's going to go through 3 kind of common repair scenarios where we have ADAS implications, starting from kind of a small bumper repair all the way to a heavier hit. And we're going to look at 3 different automakers. We're going to look at 3 different implications for ADAS. And in between each, I'm going to talk about each one a little bit. We've actually had some changes since the video was first shot, and some changes to the OEM service information that's really interesting and really important. So I guess, I don't know if we're going to show the video first, and then we'll get into it.
David Friars. I'm the operations manager here at CSN Drive Auto Repair Centers.
And I'm Nick Dominato, the Senior Vice President of Business Development for asTech. Today, we're going to take you through a few common repair scenarios and see how ADAS systems can affect that process from the beginning of the repair, from intake, all the way through to the end of the repair, and how ADAS systems might affect some common scenarios that we're going to see in a body shop setting.
Can everybody hear me okay?
Yes, we can.
Okay, so these are the vitals on the car that we're going to bring up right now. We've got a 2019 Honda Ridgeline that just came in. It had a small crack on the driver's side of the bumper. The bumper had a textured finish. So the shop had decided to completely replace the bumper instead of repairing it. They did not find any structural damage to the vehicle, but they did find some questionable or potential repairs around the sensors on the bumper. And you'll see right now that there are some pictures of the actual minimal damage that was on the bumper upon intake. You'll see the sensor there. And then this was just before reassembly.
So we have small damaged 2019 Ridgeline. It's hitting the left rear corner. It had a small repair on the box side, sheet metal repair. We did have to replace the rear cover. Textured rear cover had to be replaced. During the repair plan, we did notice that it did have a blind spot sensor. So we do put a recalibration on that. We're about ready to put this thing back together, get it detailed, and get it back to the customer. But I think there might be a little bit more, right, Nick?
That's right. That's a great catch, David. We've gone from a small bumper replacement job, and your technicians or estimators have found a blind spot sensor very close to the impact of damage. And so we're going to check the condition of that blind spot sensor to make sure that nothing moved, because we did have a little bit of damage to the box side, and we don't know how that may have affected the blind spot sensor.
Correct.
But there's more to it than that. Honda has an excellent document called Aiming Driving Support Systems that talks about when the different ADAS systems need to be recalibrated. Honda says to do a blind spot calibration, you need to do the wheel alignment prior to doing the blind spot calibration if that vehicle is being involved in a collision.
So we did do a pre-scan on this, but nothing came up on that pre-scan. So we're still going to walk through it a little bit more then, right?
That's correct. A clean scan report is not at all clear for ADAS systems. You can't rely on your scan tool to tell you whether or not you need to do a calibration. The only way to find out that we need to do a calibration is by looking at the service information and determining what operations we've done on that.
So what does this need then, Nick?
So we've got a collision right near the area of the sensor. It's more than minor damage. And Honda says we're going to have to perform a wheel alignment because this vehicle is being involved in a collision. After the wheel alignment, we're going to have to perform a blind spot calibration. We're also going to have to perform a front radar calibration and a lane keeping camera calibration because we've now performed the wheel alignment. All of these sensors are very sensitive and they depend on the thrust angle of the car to determine where the car is heading and to determine what inputs the power steering and other functions of the vehicle will make to help work in tandem with those ADAS systems.
So it looks like we're into a supplement here. I guess I'm going to have a little bit of a delay on promising this back to the customer. I'm going to have to schedule an appointment for a wheel alignment, make sure that they understand over at the dealership that they're performing a wheel alignment as well as all of these calibrations. I'm going to have to get that back and get a supplement set up as well.
That's right, David. It's important to make sure that your sublet vendors are performing all the necessary procedures in addition to the calibration. For Honda, we need to do a wheel alignment before the calibration, but Honda also requires having a full tank of gas, having coolant levels full, and a number of other factors. If that dealer is returning the vehicle to you calibrated, but with a half tank of gas, they have not performed that calibration procedure correctly. And it's up to the shop to have that accountability with their sublet vendors to make sure that they're performing that calibration in accordance with what the manufacturer says.
So there's a ton of stuff to unpack here. Honda, as of last Monday, has completely changed all of their guidance on aiming driving support systems, including blind spot, radar, front camera. Everything we shot in this video about 3 weeks ago is all different now, which is just completely wonderful. Anthony, I don't know if you can unshare so I can kind of show everyone what we're talking about here. But 3 weeks ago, when we shot this video, and I'm just going to share my screen here, this is what the Honda driving aid document looked like. And I don't know if we can all see here the blind spot information system, but essentially what we had is if the vehicle is involved in a collision 3 weeks ago, Honda said you must do a wheel alignment after a collision. And you can see it in that highlighted area there. What that meant was, for the blind spot system, you needed to do a blind spot radar aiming check after a wheel alignment. So we're in a kind of minor collision. We're doing a wheel alignment, and we're doing a blind spot radar calibration. We're doing a millimeter wave radar calibration, which also has to be done after an alignment. And we're doing a forward camera calibration, which also has to be done after a wheel alignment. This caused a lot of confusion and consternation in the industry because we were talking about, these small hits here that we just discussed, kind of 1 hour dents on a quarter panel, and Honda was coming out and on the face of that document was saying, you've got to do a wheel alignment and then you've got to calibrate just about every single ADAS sensor on that piece of equipment. As of last Monday, Honda has come out with a new job aid and a new driving support system. And what we saw in the video now would likely not lead to a calibration based on the new procedures. And you can see that they've changed things up. Essentially what we need now for Honda for that blind spot aiming is we need to RNI or replace the sensor. We're doing or if we do a mounting panel repair. So if you're repairing or replacing a panel that sensor mounts to, in this case, the outer box side wasn't mounted directly to the blind spot sensor, or if there's rear end structural damage. And Honda's got a very, very interesting definition of rear end structural that you can see here on that highlighted portion, where we're talking about the main unibody. So I don't think we're talking about kind of outer quarters or outer rockers. But Honda also says the bumper reinforcement, so the front bumper reinforcement and the rear bumper reinforcement, as well as the radiator support and the door reinforcement beams. So we're still getting in a situation where if you're doing a lot of work on Hondas, if that damage, kind of a front end or a rear end collision, if that damage has traveled to the front or rear reinforcement bar, you're still looking at, you know, possible several calibrations that you're going to be looking at. In this case, if the damage has gone to the rear reinforcement beam, Honda still says you're going to have to do a blind spot calibration. You would also have to do a millimeter wave radar sensor calibration because we've still had that same structural damage under their definition of a structural repair. And you would also have to do a front-facing camera calibration, which is also required after that structural body repair. So we've certainly seen Honda kind of narrow down these calibration requirements from saying anytime there's a collision, we need to perform a wheel alignment and calibrate everything, to kind of narrowing it down to looking at structural damage. But if you've got a repair situation where that damage has traveled to the rear reinforcement beam, then you're still looking at a blind spot calibration, a camera calibration, and a front radar calibration. So multiple ADAS calibration scenarios for damage that may not reach that, you know, high level of severity that you think would warrant an ADAS calibration just on the face of it. And Honda's done a pretty good job of actually saying, if you're doing any kind of calibration, I'm going to highlight this here, you need to perform a wheel alignment check prior to doing the calibration. And the blind spot situation that we saw in the video is a good example of why. I'm going to show you, this is a photo here of one of the tools that you need to use for that blind spot aiming check. And you can see that that kind of bar that gentleman is holding, that needs to go up right against that rear wheel. And that sets the angle for the alignment tool to be used. So if you've got a vehicle that's kind of being hit in the rear, or that thrust angle, so those wheels are off, you are now putting a piece of equipment against those rear wheels to set the angle. The thrust angle is off, that bar is going to be off, the angle it sets is off, and your results are going to be off. And that also really highlights, you know, kind of A, the importance of doing a wheel alignment check, but B, if you do have a kind of sublet vendor or a dealer who you're sending this work to, especially for Hondas, but other manufacturers as well, it's critically important that they're not just performing the calibration, but they're also performing a wheel alignment check if the manufacturers are requiring it, and fulfilling all of those other prerequisites, such as a full tank of gas, or dropping the bumper in case of some wheel alignment checks. And they're doing all of those things that are kind of necessary to actually have a safe and proper calibration so you can ensure that those systems are functioning properly.
Hey, Nick, this is Patrice here. I got a question here that came up through the chat. And it's asking about, is it possible to is it possible to share the document that you have from Honda? Is that possible to share that, or provide the information, or where you find it?
Yeah, so I don't think it's possible for me to share, just because this is a brand new document that Honda came out with. They do have kind of copyright restrictions on that, and I don't want to, it would be a violation. I saw Nina posted an article. That is most likely the outdated article. So if you see a document that is dated April 2020, that is out of date. The newest document is dated March 2021. It is available on so Honda's Tech Info site, SIS. One thing to note is it is not available on Service Express. So if you go into Honda's service information, perhaps maybe iCar has posted it by now. I hope they have. I can't check it right now, but just make sure if you see that document, it's dated March 2021. It's not available through Service Express. You have to go through SIS, which is the US-based website. But if that's dated March 2021, that should be the one.
Okay, well, thank you. There was another question that I saw in the Q&A. The question was about if the bumper cover in the scenario that we had, was that an OEM part or is that an aftermarket part? That was a question that came up here.
That I'm not sure. I'm not sure if it was OEM or aftermarket.
Okay.
I believe Honda has a position statement stating that, you know, those bumper covers, they have to be OEM, especially if there's ADAS. The interesting thing about Honda in particular is that their blind spot system is not a calibration per se. It's really just a mount angle check to make sure that the blind spot sensor is looking at the right angle at where it's supposed to be doing. And so for other manufacturers, you may be able to say if it's an aftermarket bumper, you may be able to still perform the calibration and learn that sensor to an aftermarket bumper, even though it's not perfect, although the OEMs would disagree with that certainly. With Honda, there's no way to kind of learn that sensor to an aftermarket bumper if it's a different dimension.
Okay. Okay, very interesting, Nick. This is interesting. I made a note here, a small hit, but big implication in terms of what needs to be done, what needs to be checked. So do you want to start? Do you want to look at the second case that you wanted to show? Second video?
Yes.
Okay, so this is a 2020 Sienna. This is a more obvious one for sure. It's a front left end hit. The shop diagnosed right away that an alignment would be required. There was a subframe damage. Majority of the damage on the left fender and the front bumper. They intended on blending the door. They replaced the bumper. They replaced the grille. I believe the grille was aftermarket in this scenario. The grille was equipped with a front camera, and the aftermarket grille did not come with that camera, so it was replaced. It had sensors in the front, and they did establish that it required a recalibration. And here's a picture of it upon intake. As you can see, it's pretty substantial.
So we have a 2020 Sienna here. It's had some significant damage up front. It hit the left front corner. We did have to replace the bumper cover. The headlight was damaged. Small damage on the grille, so we did have to replace the grille. But most of the impact actually was taking the left front wheel. We're taking this over to the dealership for an inspection. They've come away back with that it does need a subframe replaced, as well as the left front suspension. During repair planning, we do a pre-scan. Pre-scan came up that it does have a couple of options on there that are going to need recalibration for us. The camera systems, as well as the wave recalibration. But I think there's a little bit more to know about this, right, Nick?
That's right. As vehicles get more complex, we're going to be looking at multiple calibrations for even small amounts of damage. Take this Toyota Sienna. Even if we were just removing and installing the bumper cover, we're looking at a surround view monitor calibration and a wave radar sensor calibration.
So even just removing the mirror, if this was a small damage going to the side, would require one of these recalibrations.
If we're doing a little work to the door and we're removing and installing that side mirror for paint, we're still going to be doing that surround view monitor calibration. Once we've changed the potential angle of that camera system, we need to recalibrate. That computer sensor stitches together all four images of those surround view monitor systems, and it needs to make sure that they're looking at the right place in order to make sure that that system functions properly.
So removing the bumper cover, what are we looking at?
Removing the bumper cover, we're looking at a surround view monitor calibration. It's not the front camera. We're also looking at a wave radar sensor calibration. We take that wave radar sensor on and off the vehicle, it could be changing the angle of the radar sensor. If it changes just 1 degree, at 130 meters down the road, it's looking in the wrong lane. These sensors now with adaptive cruise control are designed to look at 200, 250, or 300 meters down the road. So even that 1 degree change can significantly affect proper functioning of that sensor.
And then this has also got the pre-collision.
That's right. And it's interesting, Toyota actually says that if a vehicle has pre-collision, is involved in an accident, that system needs to be disabled, or else serious injury or death will occur.
So a small damage on a bumper cover may be affecting that pre-collision warning system.
Any damage or an especially damage to the bumper or the grille requires that pre-collision system to be disabled. So as a repairer, you need to be thinking about what you do when you get a vehicle in with that pre-collision system.
So that small damaged bumper may actually make that vehicle non-drivable.
That's exactly right.
Perfect. Thank you very much, Nick.
Thanks, Anthony. So this is another great example here. This Sienna was blasted pretty good in the front, and so the calibrations here were a little bit more obvious. We had to replace the grille, replace the bumper cover, and of course we took the side mirror off. And so this was one where we could say, okay, you know, pretty obvious, we need to do a calibration. But I want to focus on what if the damage was smaller. So we took a look at Honda, and where we have Honda says basically if you've got structural damage that gets into that reinforcement bar on the front or rear, or the door intrusion beam, you're looking at multiple calibrations. Toyota is also similar in the sense that if we just have a bumper RNI, we've got two possible calibrations. So let's forget about the fact that this thing was hammered in the front. I'm just going to show you guys some documentation again here for what I'm talking about. Toyota is pretty clear. If you're RNIing the bumper cover, you've got two calibrations if the vehicle has those systems. What I'm showing you, this is the radiator grille. So this is the grille installation procedure. And of course, if we're taking the bumper cover off on these vehicles, the grille has to come out with it. And if we put the bumper cover back on, the grille has to go back in. And this is pulled right from Toyota's, or this is right from ALLDATA. If we're putting the grille into the vehicle, the second step is adjust the millimeter wave radar sensor assembly. So now we've got a situation where we're taking the bumper off, putting the grille back on, and now we have a radar calibration just from a bumper cover RNI. Now, if that vehicle has a surround view monitoring system, let's take a look at the panoramic here. So we can see that this is, again, from Toyota, from ALLDATA, where Toyota says, if that camera assembly has changed from a removal and installation of the camera, the bumper, or the grille, we need to perform a panoramic view calibration. So even if we've got kind of small damage, replacing the bumper or just RNIing it, if it's a highly optioned vehicle where we've got radar and a camera, we're looking at two possible calibrations. The Sienna is a really good example of you need to look at the OEM service information, and just performing the calibration itself isn't enough to know that it's being done properly. We're going to take a look at the Sienna and this adjustment here, and I'm going to take you over here, and this is the actual radar sensor installation page. And you can see here, Toyota says if the bumper cover or the grille or the the grille has been replaced, you need to check the beam axis change mechanism and measure that so that there's a 1 millimeter difference or less between those two gaps that Toyota has shown. If you were to do a calibration, your tool, if it's an aftermarket tool or an OEM tool or the dealer, that will let you perform the calibration without doing this check. That doesn't mean that the calibration you perform is correct. You need to make sure that that radar sensor is centered, and that means taking a look at that actual mechanism and doing a measurement before you perform the calibration. So critically important to read the service information when we're talking about a calibration. Not everything is contained within the scan tool or those calibration results that you're using. And just because you have a reading on your scan tool that says calibration complete, doesn't mean that it was actually performed properly and that it actually will operate in a proper fashion. If we haven't checked those gaps, in this case with Toyota, and made sure that it's aligned properly, the car will still not be returned to its pre-accident condition, and we have no way of knowing if that radar sensor will work or not. So we need to always go back to the service information and make sure that we're doing everything they need to say is done, even before we perform the calibration. Now, one thing I mentioned here was this precaution, and this is good for repairers here. And you'll see here in the following situations, Toyota says, disable the radar system. We're talking about the pre-collision system. This is emergency braking. They don't have this precaution for lane keeping or blind spot. Toyota is really talking about the pre-collision emergency braking function, which of course is a key safety feature on these vehicles. And they want to make sure that that emergency braking feature is working properly, because if it doesn't, we can have unintended sharp decelerations and sharp braking. And we've certainly seen situations where a misaligned front radar sensor will initiate an emergency braking procedure under low-hanging bridges, or if it's being towed behind another vehicle, because it's not aligned properly and it thinks that there's an object right in front of the car, even if there isn't. And that can create huge, huge liability concerns if you're driving on the highway, and of course your car unexpectedly slams the brakes on you. So Toyota says, in these situations, we need to disable the system. And you can see here, if we've had a strong, impact applied to that front bumper or grille area due to an accident, we need to disable that system. So if a customer comes in and the vehicle's drivable, but the car is equipped with a pre-collision system, as a repairer, we need to be thinking, A, we need to, if we're going to send that customer back on the road, we need to disable that system. We need to tell the customer to keep that system disabled and probably document that in case anything happens. Or B, is it safe to even put that car back on the road, knowing that once that customer gets in the car, all they really need to do is press a button and turn the system on, and something can happen down the road. So certainly some considerations for repairs when it comes to these pre-collision systems that are damaged, and what to do about it. It's more than just the calibration, it's also what to do with the car when it gets in. The panoramic, you can see here, this is a 48-page document. So this is the surround view monitor system for the Toyota Sienna. I've only printed off the first 2 pages, but you can see here, it's essentially if you touch any of those cameras or their mounting parts, you're gonna have to do a different procedure. And there's 8 different procedures across 48 pages. But if you take the time to actually read through it, this is one of those procedures that you can actually do in your shop. You need some string, you need some tape, and you may need a 90-degree tool in order to measure angles. But this is something that you can actually take in-house and do with a little bit of time, a little bit of knowledge, and of course a little bit of space. But if you're thinking, just because it has ADAS, I need to go out and buy $30,000 piece of equipment, you may be surprised that a lot of these ADAS repairs can be done by yourself, either with only a scan tool, so those kind of dynamic calibrations, or with common equipment that are in the shop, tape, string, tape measure. If you have some of those things, you can actually do a lot of those calibrations in-house, and that's something that we're going to see in the next video.
Okay, so I have a few questions here that came up, Nick. I think you probably have answered some of them along the way, but can we still, here's the question. Can we still safely drive the vehicle if the front collision is disabled?
Yes, you can. You can certainly safely drive the vehicle if it's disabled. And in that case, it would really be not much different than a car that just wasn't equipped with that feature itself. I think the question is, as a repairer, do you feel safe? Of course, you can disable the car and give it back to the customer if it's drivable, but do you feel safe about putting them back in that car, having them potentially turn it back on and then getting into a collision? As soon as you give that car back, you don't know what they're going to do with the car. And so if you're going to do that, I would say it probably makes a lot of sense to make sure you document it, properly advise the customer. So don't just turn the system off and give it back, but turn the system off, explain to the customer why you did and why it's important. Because Toyota makes it very clear that if that system is left on after an accident, it's serious injury or death can occur. It's not just, please turn this off, it may not work well. It's someone could get seriously hurt. So just make sure that you're properly documenting and informing the customer.
Okay. Another one here is with one calibration, can we resolve multiple systems? So basically, do you need all separate calibrations for all separate systems?
So generally speaking, one calibration. Yeah. So when it comes to ADAS, you calibrate the sensor and not the system. And so when you're calibrating a radar, you're calibrating that radar sensor and not the pre-collision or the adaptive cruise control. Each sensor has its own calibration requirements. And so generally speaking, if the lane keeping camera is messed up and you do a calibration of the front radar sensor, you're not going to fix that. But they do all take inputs from each other. And so adjusting the radar sensor and calibrating it will change the input to the lane keeping camera because they're taking all of those systems together. But no, you're not going to, not to my knowledge anyway, going to fix one sensor by calibrating another.
Okay. Other questions I had too is I think you mentioned that you were showing a document about all data. So that's a question that came, I think, at the end of the first scenario that you were showing. The question was all about what about all data? So I think there's some information available there.
Correct. All data is a great resource. I pulled up TIS, so Toyota information, just before this presentation to make sure that that information is up to date in all data. The Honda, these things change. I'm not going to say they change all the time. I would say if you're using all data, there's probably a good chance that it's accurate. But the Honda job aid document is a good example of a scenario where it's possible that all data hasn't got that information yet because it's a week and a half old. And so it is important to check with the OEM service information.
Another quick one here is that can an ADAS calibration be performed on a vehicle with modified ride heights, which we see quite a bit?
Yes and no. Yes and no. So if you take Toyota is a great example of this. So when you're doing a calibration on a Toyota, you can actually change the parameters around, and so you can change. It's got inputs for the height of the camera from the floor, the height of the distance of the targets to the car, and the height of the targets to the floor. And so if the vehicle has been lifted, you could change that, but you got to change everything. So there's no guidelines for how to do that and how to properly perform a calibration. Even if you can change the inputs on the height, I don't know if it would be fair to say that you're performing a proper calibration on those vehicles.
Okay. And one last one, that's the last one that I have for now is that what kind of training is available for that? There's a question here that is there any training we can send our tech to, to learn how to do these things? Because there's a procedure you were mentioning that you can, there's some of the things you can do in the shop. Is there a training resource that shops can go to?
To my knowledge, there's really not that much out there. Of course, our product ADAS Sync is a way for you as a body shop to upload your estimate and get back your results, what calibrations you need to do, and gives you a link to the procedures. You can certainly click on those and just take a read through, see what's required. Are there special tools, yes or no? And you can figure it out. But in terms of a comprehensive ADAS course, not that I'm aware of.
Okay. Hey, let's move to thanks everyone for bringing the questions in. This is great, fantastic. So let's move to the third scenario here. Anthony.
Okay, so on this one, we've got an older Infiniti. It's a Q60, still a beautiful car, but a little bit older when we're talking about ADAS and electronics on vehicles. A relatively easy repair. It was just the front door was damaged. The door was found to be on severe back order, which is common these days. So the shop repaired the door. The car had a tri-coat finish, so they had to blend the adjacent door. Upon receiving the car, there was no ADAS identified, very little in terms of calibrations, and that was found until we took a deeper dive. And as Nick mentioned, we actually managed to do some calibration on this in-house with very little, in fact. So that's the car upon entry. I believe that door is steel, not aluminum.
Here we have a 2016 Q50. We've got a repair on the door. During that repair, we did have to remove the door, remove the mirror parts off the door. We blended the back door for color, as well as blending the fenders. We removed the headlight and the front bumper. This car is now completely reassembled, ready to go to the dealer for reinitializing the headlight, as well as recalibrating the front sensor system. But there's a little bit more. Maybe something we can do ourselves as well.
That's right, David. We've taken the door off, we've taken the mirror off. Nissan is very clear in their repair procedures. If you're taking off a camera or a camera mounting part, we need to perform a fine tuning or calibration of those sensors.
And we can do this in the shop.
We can do this in-house. Nissan has published repair procedures. If you go into their service information, whether that's directly or through a third party, you can actually find those service information. For Nissan, what do you need? You need a tape, you need a tape measure, a plumb bob, a square, a scanning tool. If you have all of those things, you should be good to go.
You've got a mock-up here, you can show us how to do it, right?
I've got a mock-up here. We're still gonna send this car to the dealership, but this is what it looks like. We're gonna make two parallel lines with tape or string coming out from the front wheels. And then we're gonna take, in this case, I've used tape, but normally we're gonna use string. We're gonna extend it out 1 meter from the front of the car, all the way back, parallel with the body of the car. 1 meter past the rear of the car. And that's gonna give us the ground truth of where that camera should be looking. Because of course, when we take it off, put it back on, it can have slight deviations in that camera position compared to what it was before. So we're matching up the display of the camera, with the ground truth of our parallel lines.
Why don't we take a look at how we can do that?
Right now we're doing Nissan surround view monitoring fine tuning. You can actually control the x-axis, which is this line moving back and forth, the y-axis, which is up and down, which we'll demonstrate for you now. And we can also control the rotation of the line here. And you'll notice a change. And what we need to do is align the lines on the screen with the straight lines and the right angles that we placed on the ground.
So basically, we just want that red line lined up as close to possible as the yellow tape or the string that we put down on the side of the car.
That's correct. And once we've got it lined up, as we do here, we can press OK, and it will write to the camera and properly calibrate it. And if you notice, the camera was actually misaligned from removing and installing it for a paint. And now we've got it back to factory specifications as it should be.
So that was a good example of another calibration that's possible to do in-house. I will mention one thing, all of those wonderful properties of tape that's sold now that allows tape to be kind of moved and curved, all of those wonderful properties about tape make it a terrible, a tool to create straight lines. So I would definitely not recommend using tape to actually create your lines. That car was certainly going to go back to the dealer for proper calibration, but for illustration purposes, it was good enough. And Nissan and Infiniti are really a good example of cars. They have surround view all over them, especially once you get into the Infinitis. It's just a very common feature on those brands for some reason. And so it's one that we run into quite often. If you're taking the bumper off, the grille off, the trunk lid off, the door or the mirror off, you're going to have to do a camera calibration. And this is another good example of one that you can do in-house. It's some string, it's a tape measure, you got to make sure that your lines are square and parallel. But if you have all of those tools, it's something that you can do in-house. It's not a ton of space. And so I think as a repairer, if you're interested in getting into ADAS, there's a lot of operations that you can actually do without the need to go out and spend $30,000 or $40,000 or $50,000 in tools, especially if you're working on a few brands more than others. I would certainly recommend that you kind of go into the service information and just take a look at what kind of calibrations are we sending out, pull those procedures and see, isn't maybe something that we can do without special service tools? And if it is, then I think it might be worth your while to go in and see if it's something that you can start performing yourself. And I'm just going to share with you here. This is Nissan's document that I referred to in the video of calibrating the image. And you can see here Nissan's pretty clear that you need to perform that calibration and the writing if you've removed or installed or replaced the camera or the camera mounting part, so the grille, the door mirror, or anything else which mirrors Toyota's. And that's very common kind of across manufacturers. It's a good rule of thumb. If you're doing work on a car that has surround view monitoring and you're taking a part on or off, then it's likely that you need to be thinking about, is there calibration involved? There's certainly some OEMs that don't have that, but Honda, Acura, Toyota, Nissan Infiniti are all great examples where if you're touching any of those parts with a camera, you're going to have to do a calibration.
Okay, so I had some questions as well that came up. One was in reference, and I think that Anthony kind of answered that in writing through the Q&A, but the question was about the scan tool that was being used for the demonstration, the alignment you did. So Anthony answered that Autel was the one that was being used for this. And another question that I have here from Cody is, are these in-house type of calibration becoming more or less common with newer vehicles?
That is a fantastic question. I think that,
I think so.
you know what, to be honest, I don't think that is the factor that changes it, older or newer. Take Nissan Infiniti, that calibration procedure with the lines and the parallel lines, that's the same for 2013 Infiniti as it is for 2021. It hasn't changed. Toyota is the same way. So if they have a kind of static procedure that you can do in-house, chances are it's going to be the same for 2013 as it is for 2021. There's some talk in the industry about calibrations moving towards dynamic. So that's, driving the car. If you've worked on kind of the 2021 Camry or some 2021 Toyotas, there's now the option to calibrate those ADAS systems dynamically. I don't think the industry is going to go that way, but I wouldn't say that it's the year that's going to be the deal breaker on changing from in-house or not.
Okay. So, hey, folks on the line here, just a few more minutes. If you want to ask questions, just enter your question in the Q&A.
Patrice, I will bring something else up. Yeah, your question earlier about calibrating vehicles with aftermarket equipment. I had a very good conversation with someone from Honda last week, and certainly, especially if you're in the Western provinces or in rural areas, you'll often be in a situation where you have to do a calibration on, let's say, a work truck that's got tools in the back and it's got the rack in there, and they're never taking that out. And so the question is, do you do a calibration on that vehicle that's loaded down with that work equipment, or do you take it out? And at least for Honda, and this pertains to aftermarket systems, because having a truck loaded down with tools is very similar and has effects on the vehicle in the same way that a lift kit would. And Honda's answer is to do the calibration properly. If you've got a work truck with tools loaded in the back, you need to take those tools out of the vehicle, perform the calibration, and put them back in. Okay. So at least from Honda's perspective, it would suggest that you need to perform, if a vehicle has those aftermarket kits on them, you wouldn't be able to perform a proper calibration if you can't take those off.
Okay. Well, thank you. That makes some sense. So, hey, Nick, fantastic. Thank you very much. That was excellent. That really was excellent. And something I forgot to mention at the beginning when I was introducing you is that you do sit on the CCIF steering committee as the young and filling the seat of the young entrepreneur. So thank you very much for your participation on the steering committee as well. So great presentation. Anthony, who's sitting in the back running the video here. Thank you very much as well. and as well as David Friars. I mean, wow, what fantastic. I mean, that was very nice of David to open the doors of his shop and really showing with us, I mean, some of the work that they are doing, some very live work. So that was great. That was fantastic. So I hope I got, I think, one more question here that came. Are calibrations needed as part of regular service maintenance?
The answer is yes. The answer is yes. So the longer answer is it depends on the OEM, but there's a number of manufacturers that say if you perform, for example, a wheel alignment, you need to perform a calibration. Volkswagen, Audi are big ones. Ford's another example. If you perform a wheel alignment, you need to adjust the lane keeping camera. Or they say if you do any suspension work, you need to perform a calibration. Toyota used to say that, they don't really anymore. But you need to look at what the specific OEM says. In many cases, yes, if you're doing the kind of light mechanical work, alignments, changing out suspension parts, you're going to run into an ADAS calibration.
Okay. Okay, well, thank you. I think we're reaching the hour here. I'm just going to do a quick share here of my screen, and thanks everyone for attending this event. Thanks again to Dave for his participation. This session has been recorded, so it will be available at ccif.ca. Give us just a few days to do small edits here and there, and making sure that it's that it's available. But just go to ccif.ca and you will find the recording of the session. And don't forget about tomorrow's session that we had at 11, same time, different day. And thanks again to our sponsors. I mean, again, this wouldn't be possible if we wouldn't have the support of all those great sponsors. So thanks for the support. Thank you everyone for attending. We were close to 200 participants, which is a pretty good number. I'm happy with that. I mean, the first webinars that we ran in December, we were around 100. Now we were close to 200 today. So thank you. I really hope you enjoyed it. Reach out if you have any comment, any questions. I would be more than happy to follow up with them. And again, thank you very much for attending this webinar here today. And I'll see you tomorrow. Thanks, everyone.